Alright, Chapter 22, Railway Accidents and Disaster Management. An occurrence that does not make effect for the safety of the railways, its engines, rolling stock, permanent way of the works, the passenger personnel, the cause of delays, train off the rails, is termed an accident. And duty with every railway personnel to take the following action whenever the accident occurs. Notice. They take immediate steps to stop the train if it's still in motion, since after the further movement is likely to worsen the situation. Provide all possible assistance in order to relieve the injured and stranded passengers. Take immediate steps to remove any obstruction, remedy the situation. Do whatever that is able to do competently. Report the incident near station masters as quick as possible means. Train accidents. In pursuant to the recommendation Railway Accident Inquiry Committee 1978, the Railroad Board has decided that all the increased incidents shall be result in mishaps should be determined that train accidents can broadly be classified under the two distinct categories. Consequential train accidents include collision, derailments, accidents, level of crossings, train fire, similar accidents that have serious repercussions in terms of casualty, damage to the property, miscellaneous train accidents. This includes certain type of train accidents that do not come over the first category. For example, the accidents where a train run over the cattle without any ensuing derailment, also caused during shunting and in the yard sidings. Serious accidents. Every incident that affects the train or caused by the train resulting in loss of human life, damage to the railway property, excess of 2.5 million or 25 million occurs a result natural case for the landslide but reaches flood of the derailments in which leave the interpretation of services is important, but the line of the communication at least 24 hours is deemed a serious accident. Indicative accidents. Indicative accidents include those accidents breach of the block rules, averted collisions, transportation danger signals, equipment failures, unusual occurrences such as mishaps not categorized in trade accidents. Also, indicative accidents on Indian railways it is practiced sudden different type of the hooters according with the type of the accidents occurred in table indicated in 21.1. Accident locomotive shed the traffic error according with the legend locomotive shed 2 long hoots. Accident 1 station main line and clear 3 long hoots. Accident out of station where the main line clear and relief train is accompanied by medical car 3 or 4, 3 long 1 short. Accident 1 short 1 station or out station was main line is blocked. Relief train is not accompanied with a medical car 4 long hoots. Accident out station main line is blocked with the relief train is accompanied by medical car 4 long hoots 1 short. Whenever there is an accident resulting in damage in any part of the permanent way affecting the free of the passenger train with a permanent way inspector a assistant engineer section should produce the accident site with as soon as possible minimum material required for the deal with the emergency should be collected on the way of the site. In this case, the traffic interpreter of the divisional engineer should be processed with the site of the circumstance of the gate for the hand required personal supervision guidance in the event of the accident taking place on the division point where the assistance could be more expendious rendering officials of the adjacent division officials should be alerted. These officials should be proceeded at the scene of the accident immediately, rendering all possible assistance. 22.2. Classification rail accident. The rail accidents category of the different category classes according to the type of the accidents. Table 22.2. Group A, collision. B, derailment. C, averted collision. D, train passing danger signal. E, breach of block rules. F, fire in the trains, etc. G, train running into the road traffic level. H, failure of engine rolling stock. J, failure of permanent way. K, train wrecking. L, other train trolley accidents. M, casualties. N, unusual incidences. P, miscellaneous. Out of the accident table 22.2, there are most important ones of the discussed and detailed following subsections. Collisions rather than one train crashing and running into another, the rolling stock, the type of the accident dreaded for the most, they thoroughly constitute 7% of all the accidents, responsible 38% of the total number of deaths. The 3 major type of the collisions, namely head-on and rear-end collisions, side collisions. The main cause being the collision of the failure of the station staff, the technical staff, to carry out the duties effectively, failure of the drivers due to the communication error, the remedial measures of avoiding collisions are followed. Develop human and resources bound signals technology, electronic gadgets, and technology compensate for the error. Human judgment mostly consists of the improved signal method, the initiative of the electronic system. Some of these technologies include automatic blocking system, continuing track circuiting, automatic train protection warning system, proving axle counters, panels, and solid state interlocking anti collision devices. These systems send out the timely warning, automatically apply the brakes to prevent accidents in the case of the error and human failure. Derailments occur when the train skids off the track because of some of the obstruction of abnormality. The main cause of some of the derailments of the defects, the vehicle defects, signaling, the interlocking defects, human failure, including defective operation, railway equipment, other miscellaneous cause of the remedial measure for preventing the derailments as follows. Improve the track structure, track maintenance procedures, use modern railroad rolling stock with planned maintenance schedules, use modern signal electronic equipment with initiative techniques developed in human resources. Accident level crossings. Out of the 37,000 16,345 level crossings existing in Indian Railways. On March 31st, 2004, only 16,607 level crossings were manned and had gatekeeps. The rest were unmanned and did not have gatekeeps. Only 14,500 less level crossings had telephone systems connected to them stations. Train fires, particularly fire passengers, take the heavy toll with the life of the property. The fires may occur due to short circuit of the wiring of the coach, presence of the inflammable materials such as petrol, kerosene, oil, gas cylinders inside of the trains. Following measures have been taken to avert train fires. Designing of the coach. Wooden coaches have been replaced with steel coaches inside of the coaches, gradually being equipped with fire-resistant material. Electrical lighting railways have been switched over the gas lighting and electrical lighting. Even the case of the short circuit of the 24-volt system draws the heavy current caused the electrical wiring to get overheated, resulting in the fire in the coach. In view of the danger of the Indian Railways gradually changing the system of the 110-volt, which will reduce the possibility of such fires. Publicity capacity. Even though the railways have strict rules regarding the transportation of explosive dangerous materials, these rules need to be implemented more rigorously. The railways introduced a new publicity of the commands to educate the public in this regard. Accident due to flood and breaches of railway bridges and embankments are likely to be affected due to the heavy rain and sudden cloud bursts. The result of flood and breach of the by creating unsafe condition tracks causing accident. Therefore, following the safety measures can be taken during heavy trains to ensure the safety of the track. Gang patrol during the abnormal rainfall storm of the check damages, adding of the track bridges, night patrolling during the monsoons to detect damages, if any, caused by the flood, including breaches, settlements, slips, and scores, and taking immediate action, perceiving any damage to protect the trains. Daily foot patrolling key men to inspect the entire track. The key men should also be immediately act upon the discovering unsafe conditions. They must result unexpected occurrences such as rain and floods. Watchmen should be stationed in vulnerable locations such as bridges and floods, causeways in order to provide safety railway tracks. 22.3 Derailment and its cause. I mentioned earlier on all the various types of railway accidents. Derailment is the most common. In the case of the derailment, an engine wagon skids off the railway track due to one or more irrelevant factors crossing the safe limit. Derailment may generally be of two types. Such sudden derailments are due to the wheel jumping off the rail. The type of the derailment is not characterized by mounting mark of the rail. The drop mark of the sleepers occurs. The derailing forces are high enough to force the wheels to suddenly jump off the rails. The probably cause of the type of the derailment is listed below. Excessive speeding, particularly on the curve of the turnout, sudden shifting of the loads, improper loaded vehicles, sudden variation in drawbar forces caused due to the braking acceleration, proper train operation, resonating, rolling, arising, and hunting, broken wheels and axle, failure of vehicle components, presence of some obstruction of the track, failure of the track components in both wheels do not inside of the track, the mis cause of the track distortion, gap, gauge expansion. Alright, gradual derailment of the flange climbing. The type of the derailment is caused with the wheel flange climbing onto the rail. This leaping the mounting mark for the rail to touch the derailment curve of the derailing force to overcome the stabilizing force, but are not high enough to ensure the sudden derailment. In this case, the unstable condition of the track causes the wheels to climb into the rail and riding over it, finally slipping off it and sliding off it. The difficulty to establish a primary fascia behind this kind of the derailment. Detailed investigations need to be carried out so that the final arrive at the exact cause, the same as the reason such as the accident maybe a single joint effect of the following: track defects, vehicular defects, unfavorable operating techniques. All these causes further elaborated in 22.3. Failure formation, unequal sediment slip in the submergence yielding formation, water pockets, pressure failure of the rails, fracture of the corrosion rail, failure of sleepers, older broken sleepers, gauge variations, excessive slack of the gauge equal to 19 millimeters per minute on curves, cross level to high variations across level to super elevation, 75 millimeters per minute on curve, defective maintenance, opening of the out of the long welded rails in hot weather, missing of the broken fittings, adequate ballasting, poor track geometry, vehicular defects, flange defects, the thin flange, sharp flange, worn out route false flange, flat tire, wheel detects the more the permissible difference of the wheel tread diameter, excessive wheel gauge, defects in angle box, axle guards, hot boxes, broken axle, defects, axle faceplate, bent axle guards, broken, brittle bar, spring and camber defects, effect of the three camber, difference of the working camber, broken springs, cracked shackle pin, burner defects, buffer defects, deep dead buffer, unequal buffer heights, defective buffer, dropping buffer, cracks in the heads of the buffer, underframe bent defects, bent head defects, deficiency truck, slowed bracketed out of the square trolley, breakout joint, breaking drawbar, brake defects, deficient brake block, broken gear bars, missing braking system deficiency, safety hanger, unfavorable operating techniques, excessive speeding, eccentric load, sudden shift in load, sudden braking, acceleration, wrong marshalling of a train, empty wagon marshaled between two loaded wagons. Alright, 2231 derailments on turnouts. And large number of derailments occur with the turnouts because of where the vehicles change on the track they are. The reason the derailments are generally as follows: improper manipulation of planes, gapping points, traffic defects, worn out wheel flanges, high wing rails, low crossing bolts. 23.2 Naudil's formula of derailment analysis. The time derailment wheel flange are products of the climbing out of the rail. Certain factors point with the contact with the rail and the wheel while the line at positive angularity each shown in figure 21. Naudil's formula is a safety against the derailment. Y over Q is greater than tangent of B minus U plus U tangent B. 22.1 Forces of rail wheel contact positive angularity. Y. Y is the flange of the forces. Q is the instant wheel load. R is the normal reaction. U are the frictional forces upwards. U is the coefficient of friction between the wheel flange of the rail. The B is the flange angle. Y and Q is known as the derailment coefficient. Naudil's formula provided with the important criteria of assessment of stability of the rolling stock is a practical youth investigation of derailments based on the Naudil's formula. The factor contributed to derailments whether due to track defects, vehicle deflects, unfavorable operating techniques such as are as follows: increased flange of force on Y, flange force, decreased instantaneous wheel load, increased coefficient friction between the wheel load and the rail, normally consequent with the rusted rail, newly turned wheel, ending of the rail, sharp flange, etc. Increase the positive train angle of attack conditions, increase the positive eccentricity, and increase the primary due to the slope of the wheel flange becoming steeper, improves the angle of running of the axle. Restoration of traffic. After necessary information collected, immediately prompt action should be taken to restore the traffic on the line. In case of the causeways, it may be necessary to restore traffic, making temporary arrangements such that the insertion of the rail cluster provision with the temporary diversion arrangement should be made with the adequate labor. Permanent way with the material damage of the track should be attended as soon as possible. It may be emphasized with the adequate labor the most predominant requirement of the restoration of the traffic. All engineers and inspectors should be thoroughly acquainted themselves with other possible sources where the labor can be readily obtained in the event of the breach of serious derailment in this section. 22.4.1 Diversions. Diversions are set up at these points of the track where there is such obstruction, where some of the reconstruction work is in process. They may be classified in two main categories: temporary diversion constructed without obstruction of the traffic, which are not likely to be more than 10 days. Semi-permanent division constructed for the special purpose of facilitating reconstruction line bridges, which are likely to be used for a period of more than 10 days. All trains must be entering the temporary division proceed at a highly minimized speed. On a semi-permanent division, their train may not be stopped and reduce speed only after the adequate part of the period of construction. Normal semi-permanent divisions are provided with the Indian Railways with an initial speed requirement of 0, therefore they are relaxed in consolidation of the bank. Semi-permanent divisions shall be laid accordingly to the specification in Table 22.4. Geometric elements of semi-permanent permanent divisions. Radius of the curve, broad gauge not less than 45 meters, or meter gauge not less than 300 meters, narrow gauge not less than 45 meters. Gradient not steeper than 1 to 20, 100, 1 to 100, not meter gauge 1, not steeper than 1 to 80, not steeper than 140, narrow gauge. Super elevation. Narrow super elevation is provided with it should be limited to super. The permitted diversion should run out of the rate of exceeding 12 millimeters, 1/2 inch, or 10 meters, 30 feet. Condition stands in Table 22.4 with the desired semi-permanent diversions have the following feature. The existing bank should not be cut to delay the diversion. The gradient should be suitable to compensate with the curve in the degree of the nature of the spite of the curvature of the gradient does not exceed the limiting value specified in Table 22.4. If the diversion includes the bridge curve at the straight level, the portion of 30 meter of 100 foot should be provided with the approach to the bridge. The guard existent against a possible segment diversion blanket of the coal ash should be provided with a new embankment that rolls this if possible. Plan and longitudinal section diversion. The plane land it ensure the diversion setting of the illustrated 22.2. The formula is now used in conjunction with the same as the following. Alright, plan figure 22.2, plan and longitudinal section diversion. Minimum 30 meters straight level of S1, L1, S2, S2, L1, radius RR, tangent TT, straight level and plan 30 meters. Level existing on the bank, gradient of 1 to 100, straight and level, gradient 1 to 1 to 100, level existing on the bank. L is equal to the square root of c squared plus 4rd, 4 times rd times d squared plus s squared, or t is equal to rd over s, td is equal to rd over l minus s divided by 2 plus c. Where L is the length of the diversion measured along with the original alignment, D is the maximum distance of the diversion original alignment, C is the straight line between the two reverse curves connecting the original alignment to the diversion, which is not less than 30 meters or 100 foot. The S is the straight position of the diversion parallel original alignment. The R is the radius of the curve. T is the length of the tangent. Alright, 22.5, flood causeways. Causeways gets flood velocity. The water is not too high, but the trains may be allowed to pass subject to the following conditions. The permanent way inspectors examine the track on foot and satisfied to be safety and integrity of the permanent way. The depth of the water not exceeding the following limits. The broad gauge 300 millimeters or 450 millimeters. Good trains. Meter gauge 225 millimeters. Passenger trains 225 millimeters. Good trains. Narrow gauge 225 millimeters. Passenger trains 225 millimeters. Good trains. When the track gets flooded, the train should be made to a halt to proceed to the stop at the speed of 8 kilometers an hour, subject to the following condition. If the water rises over the ballast level, it remains from below the light rail level, then before the passing of every train, at least 2 men should walk abreast of the length of the track on either end of the sleepers. Train should be allowed to pass over the track undamaged. Whether the water come over the rail or the permanent way, inspector should conduct the probes along with the length of the track in order to ascertain with the safe and only the trains be allowed to pass. Alright, 22.6 safety measures on Indian railways. Indian railways have given the high priority to safety train operation that has helped with minimizing train accidents. Some of the important safety measures taken by the railways are listed below. The measures are regularly intervaled with the railway administrative new measures adopted, and based on these reviews, as well as the recommendation commission of the railway safety and departmental inquiry committees. Rehabilitation assets of the track and bridges and rolling stock, inspection of signaling gear, wagons, locomotive maintenance depots, quality checks, workshops, monitoring train performance, operational staff, counseling drivers really above the driving techniques, suspension technical aids, auxiliary warning system, axle counters, route relay, interlocking track circuiting, surprise checks, the verifying non-inflammable explosive substances being carried on passenger trains. G. Provide whistle boards and speed breakers at the road sign at unmanned level the crossing making provisions to improve the visibility of the drivers. Audio-visual publicity of the educated road users how to safely use the level crossing, how disaster management cover the staff and the officers training institute, making the safe of the railways multiple disciplinary fair effectiveness. 22.7, disaster management. Disaster sign with great commodity with regard to the distress and passionate staff of the families. Context of the railway disaster management invades expeditious, orderly, effective, adequate relief measure. In the case of disaster, the term disaster management first came to be used in Indian Railways in 1986 when it has been vague ever since. In some of the respects, their term defines accident as disasters. Classification of disasters. The following chart gives the broad classification of disasters on the railway. Disasters, natural disaster, earthquake, flood, cyclones, disasters related to train accidents, fires and trains, collision, derailments, level of crossing accidents. 22.7 to detail the disaster management. Disaster management rails may be divided in the following stages. Disaster mitigation prevention stage consists of the strength of the basic infrastructure such as the track, bridge, the rolling stock, signaling equipment, as well as introducing systems producing and ensuring the accidents are minimized and prevented. Disaster management planning and preparedness. Successful measurement of the disaster depends on ability to foresee, control, and time planning of the vital and minimizing disaster effects quickly, recovering resumption of the work, either developing effective disaster plan and anticipating every possible vulnerability, taking the appropriate action to tackle the same effectively in the context necessary to identify the available resource, utilize them the most efficiently due to the various officials should be defined and detailed work that can be proceeded as part of the plan strategy. The management should be fully prepared to face the disaster, should possess a proper action plan for the dealing the same. Post-disaster management, including rescue and relief management, the compromise of all the work is undertaken at the railways following the train accident. First responsibility of the rail. The first responsibility of the rail is in the case of the accident, reach the extricate accident victims to organize effective trauma care. The basic principle of the trauma management and speed, the expediency of the most trauma patients that can be saved within 1 first hour. This hour is called the golden hour. Accident relief measure. The railway has full-fledged arrangements to rescue the relief operations in case of the railway accident. Step must be taken to provide prompt, efficient relief to affected passenger in the event of the train accident. Relief train. Depending on the type of the accident, the relief train equipped with the tool vans and medical van must be arranged to proceed with the site of the accident within stipulated time. Restoration process. Rescue relief management has been made with the affected passenger. The necessary information has been collected from the site of the investigation. Perfectly immediate action must be taken to restore the traffic on the damaged track. The incumbent following the work. Mobilization adequate restore the consistent amend material equipment and specialized machinery. Restoration work of the part of the local assistance heading the joining of the division of zonal awareways should be also be taken. And if necessary, contact can be established with the villagers, local administration, civil authority, defense establishment, necessary aid. Restoration work should be immediately by the way to remove the debris, establish a new track connection. The necessary earthwork has been done in the case of the bridge. Effective with the earthwork division, temporary bridge can plan that once the damaged track has been repaired, trains are allowed to transverse and restricted speed, which slowly restore the normal speed of subsequent stages. All efforts must be made to ensure the restoration work is done expeditiously. The train starting and has been effected as soon as possible. 2273 action was taken by the engineer official. The engineer officials arrive at the site of the accident should take the following. Take the steps to protect the train, coordinate the first aid of rescue efforts, carry out the cursory examination of the entire site, advise the nearest station master, carry out the detailed examination of the site, draw the dimension sketch of the site, given the full details, collect the preserve the clues pertaining to the accident, record the track geometry, make measure the vehicle after it has met with the accident, examine the operating features, prepare the preliminary report, lay out the following up action taken in regard to repair. 2274 availability of the resources. Availability of resources are case of the major accidents may be grouped into 4 different units depending on the time frame which they may be available to after accidents. These groups are as following: Resource Unit 1, Railway, Non-Railway resources available to the train and nearby surroundings. Railway Unit 2, the Railway resource available to accident relief train, medical van, accident relief van, train depots elsewhere in the division. Railway 3, Unit 3, Railway resource of the depots and elsewhere adjoining zones. Resources, Unit 4, non-railway resources available to outside the division. 2275, unlifted command sentry combine assistance relief enclosure. 2 aspects of the disaster work carried out by the accident site to discuss below. Rescue relief restoration operation was carried out with the one side of the functionary work was done by the uncontrolled unified command center of the Indian Railway. The second aspect pertains to the rehabilitation accident affected the passenger, taking the dead body of the dead, dealing with relatively dead victims, etc. For the different sets of the functionary as required. The work is done by the combined assistance relief enclosure of the Indian Railways. 2276, review of the disaster management. High-level committee was constituted in September 2002 to review the disaster management. Indian Railways modernized the committee presented with the recommendation report April 2003, with subsequent approval to accept the implementation of the recommendation would require the estimated $4 million. Various aspects would help the modernization disaster management given them below: the faster response, better facility equipment, expanding resource, the most recent requirements, major accidents, better customer focused training, preparedness. Summary: accident derailments result in heavy loss of life, property disruption, and national normal traffic accidents classified different group depending upon the nature and severity of the more severe accidents, collision, derailment, the fire accidents. Although it's practically impossible to eliminate accidents completely, attempts that should be made to reduce the probability as much as possible. Disaster management helping deal with the aftermath of train accidents. Chapter 23, Level Crossings.